Hi everyone, it's Japoo, and today we're going to be talking about sign charts. So before we get started, I just wanted to remind you guys that a link to this worksheet and the answer key is in the description below in case you want to follow along or anything like that. So a sign chart, spelled S-I-G-N, not S-I-N-E, is not a graph of a function, but it actually tells you where things are positive and negative for that function. Technically, sign charts are not a calculus topic, but you can use sign charts in calculus problems to help you get the answer. So like for calculus topics such as concave up or down or relative min or max, you can use sign charts to help you get to the answer. So you're not going to have problems that straight out ask you to find the sign chart of a function like you would derivative or integral problems. Like you're going to have problems that'll ask you to find the derivative of a function, but you won't have problems that ask you to find the sign chart of a function. All right, so the first step before drawing the sign chart is factoring. You have to factor the function as much as possible. Factoring the function as much as possible will make this process a lot easier. And now there are two other things that after you factor the function as much as possible, you have to know in order to draw your sign chart properly. One of those things is end behavior. And end behavior has kind of two parameters that you need to look at in order to determine which one it is. So basically, you want to know whether the function will be even or odd, and then positive or negative. So the coefficient of the leading exponent of f will either be positive or negative, and that'll tell you whether the function is positive or negative. The power of the leading exponent will either be odd or even, and whether that power is odd or even will tell you if the function is odd or even. It's really easy to answer both of these questions if you factor the function as much as possible. So as you can see, the first end behavior that I'm going to draw is even positive. Even positive is just a normal looking parabola. And so if you have a function that its coefficient of the leading exponent is positive and the leading exponent is even, then that's what your end behavior is going to look like. That's what the end of your graph is going to look like. And next we have even negative, and that's very similar to even positive. It's just flipped upside down. So it's like an upside down parabola. Then we're going to have odd positive, and odd positive is kind of like a squiggly line. It's going to look something like this, like that. And then we have odd negative as our final one, and it's going to look just kind of the flipped version of odd positive. Sometimes it's a little difficult to remember which way odd positive and odd negative go, but just memorize which ways those function goes and you'll be set for sign charts. The second thing that you need to determine before you draw a sign chart is the zero behavior of the function. So basically, when you factor, you're gonna find the zeros of the function, where that function equals 0, and then you look at the exponents of all of your zeros to determine whether the sign chart will bounce at that 0 or go through at that 0. This might not make a lot of sense right now, but we will be doing some problems in a minute, and that'll probably help kind of put to practice what all these rules are. All right. So let's get to it. Problem 1. Again, factor as much as possible. That's very important. It'll make your life so much easier. So for number 1, we can see that when we factor first you want to take out the negative, right, to factor. Because it's easier to factor when your first like exponent thing is positive. So we're going to take out a negative. So that'll give us x squared minus 4x minus 12. and then we're going to factor that polynomial, and that'll give us negative x minus 6 times x plus 2. And x minus 6 and x plus 2 are in parentheses. So as you can see, our first step was factoring as much as possible, which we just did. And now we're going to determine the end behavior of the function. So for this function, the end behavior is going to be even and negative. We know it's negative because the exponent of the leading coefficient will be negative. As you can see, x squared, which is the leading exponent because the 2 is the highest exponent in that function, is negative. And if we look at the original function, we can see that the 2 is positive, it's even. The exponent 2 is even, so that's why it would be even and negative. The way that I like to actually determine whether my functions are even or odd is look at the zeros that I've just factored out and then add up the exponents for that for those zeros. So as you can see, in this case, we have two zeros. We have x minus 6 and x plus 2, and they're both to the power of 1, right? So that's 1 plus 1 equals 2. 2 is even, and that's how we know that our end behavior will be even. And then since we took out a negative beforehand, we can clearly see that this function will be negative. So we'll have even negative as our end behavior. Our zeros are very clear since we factored this function. Our zeros will be 6 and negative 2, right? So now we're going to go ahead and draw our sign chart. We're going to mark down our zeros, negative 2 and 6, on a little line. And then we're just going to draw our function. Now, this drawing does not have to be exactly what the function looks like when you're graphing it out. We're basically just trying to see where things are positive and negative, right? So we're just going to look at what even negative end behavior looks like, and that's an upside down parabola, right? So we're actually just going to draw an upside down parabola based on our determination of what the end behavior is. So we know that since it's even and negative, the function is both going to start below the number line and end below the number line, right? Now, we don't know, based on the end behavior, whether or not the function is going to cross over the number line into the positive half of our graph, but since we know the zero behavior, we can figure that out. So both of our zeros have 1 as an exponent, right? And since 1 is an odd number, and based on the rules that zero behavior follow, odd exponents mean that the function is going to go through the number line at that number. So we're going to actually draw our function to go through the number line at negative 2 and negative 6. And then we're going to mark where the function is negative and positive, and that's our answer. That's the sign chart. That's all you have to do. All right, let's keep going. So our next problem, again, factor as much as possible. So we're going to take out an x, and then we're going to have x minus 3 squared as our final answer. You can see I'm like taking steps kind of to factor this. I took the x out first, and now I'm going to factor the larger polynomial, but our final answer will be x times x minus 3 squared. So in this case, we're actually going to have two zeros, right? We're going to have x and x minus 3. However, if we add the exponents for our zeros, x is to the power of 1 plus 2, since x minus 3 is to the power of 2, our final answer will be 3, right? So that's an odd number, so this function will be odd, and then since there's no negative anywhere, we know that this function is positive. So our function now is going to be positive and odd. So if we kind of glance over, we can see what the end behavior is going to look like. It's going to start negative, and it's going to end positive. So we're going to write down our zeros on the number line first. And since the exponent of x is 1 and it's an odd number, the function is going to cross through at 0 and go to the positive side of the number line. And then it's going to come back down and actually bounce at 3. Since x minus 3 is squared and 2 is an even exponent, the function is going to bounce at 3. So our function for our sign chart is basically going to look something like that. And then we're going to obviously mark where the function is negative and positive. And then that's the answer. All right, next question, number 3. Again, we're going to factor as much as possible. So basically I switched the negative x squared and the x, so I got negative x squared plus x. And then that is equal to negative x times x minus 1 because I just took out an x. That gives us an even negative end behavior function because we can see that there's a negative in front of the x, negative. And if we add the exponents of our zeros, x is to the power of 1 plus x minus 1 is to the power of 1 gives us 2 as our final answer, which is even. So we have even negative. Even negative means that the function is going to start negative and end negative. And since both of our exponents for our zeros are odd, that means that the function is going to go through the number line at both of those points. So we'll end up having a sign chart that looks very similar to our sign chart in number 1. The only difference is where the zeros are, and that's really it. And then we're just going to mark where things are negative and positive. Or I guess I forgot to do that, but it'll be negative for anything below 0, positive for everything between 0 and 1, and negative for anything after 1. All right, number 4. So just keep in mind that when factoring, I always like to keep my factors or my zeros as x plus or minus something. So when I see the 2 minus x in this problem, I want to switch it around and make it negative x minus 2. And that'll actually help us in determining whether the function is positive or negative. So if we follow that rule and kind of make sure that everything is x plus or minus something, this is what we're going to get as our answer. Since we took that negative out of 2 minus x to kind of rearrange the form, we see that this function is actually negative. And it might have been hard to spot that if we didn't make sure that all of our factors were in the x plus or minus something form. So now that we have all our factors, all our zeros, we can add up the exponents for our zeros. So we have x minus 1 to the 2, so that's 2, plus x minus 2 to the 1, so 2 plus 1 is 3, and then x minus 5 to the 2. So that's 3 plus 2, 5. So we know that this function will have odd end behavior. And since we already talked about the negative, we know it's going to have odd negative end behavior. So we can go ahead and jot that down. And we're going to mark our zeros. We have zeros at 1, 2, and 5, right? And we know for odd negative that the function is going to start positive and end negative, right? And now we just have to look at our zeros and see where the function crosses the number line and where it bounces. So it's actually going to bounce at 1 since x minus 1 is squared. It's going to cross the number line at 2 since x minus 2 is only to the power of 1, which is an odd number, and is going to bounce again at 5 since x minus 5 is squared. So this is what our sign chart is going to look like, and then we're just going to mark the positives and negatives, and that's the answer. Now we're going to move on to number 5. So for number 5, I'm going to take out an e to the 2x when I'm factoring, and I'll eventually get e to the negative e to the 2x times 5x minus 7. So I know that the e to the 2x seems a little bit daunting, but we can actually just ignore that part of the equation when we're doing sign charts. e to the 2x only affects the graph of the function, but since we're not drawing the graph of the function, it doesn't really matter. E to the 2x is always positive since e to the anything is always positive. So it doesn't really affect our sign chart whether it's there or not. So we can just kind of cross it out and ignore it. So basically what we're going to have is negative 5x minus 7. So that negative indicates to us that our function will be negative, and it's going to be odd since 5x minus 7 is to the 1 power. So now that we know our end behavior, we know that the negative odd function means that this function will begin positive and end negative. And the 0 is 7 over 5, and since it's to the 1 power, that line is just going to go straight through. You literally can just draw a straight line through 7 over 5. Number 6, we kind of do the same thing that we've been doing. It looks a little more complicated, but it's really not. It just has more factors in it. So basically for this, what I would like to do to kind of approach it is take out every common factor that both of the parts of the sum have, and then group everything that's left together. So we can take out an x cubed, and we can also take out an x plus 6 to the third, or to the 3, sorry. And we're going to have everything that's left over, which will be x squared minus x minus 6. And then we're going to factor that x squared minus x minus 6 to get x plus 2 and x minus 3. So our final factored equation will be x cubed times x plus 6 cubed times x plus 2 times x minus 3. As we can see, that whole thing is just going to be positive. It kind of cut out a little bit there, but I can repeat it again if we need. It's x cubed times x plus 6 cubed times x plus 2 times x minus 3. I think the x minus 3 is what's cut off there. So as we can see, there's no negative. So this function will be positive. And if we add all of our exponents together, we're going to get 3 plus 3 from x cubed and x plus 6 cubed, plus 1 from x plus 2, plus another 1 from x minus 3, which will give us 8, I believe, and that's an even number. So the end behavior for this function will be even and positive, meaning that it begins and ends positive. Then we're just going to draw out our zeros. We have negative 6, negative 2, 0, and 3. And we're going to actually go through negative 6, go through negative 2, go through 0, and go through 3. Since all of our exponents in this case are odd. All of our exponents are odd. So we're going to just kind of curve through and go all the way through each of the points. Then we're just going to mark what's negative and what's positive and move on. All right, number 7. We're gonna have a difference of cubes in this problem, but we're just gonna factor as usual. So what we're eventually gonna get is e to the x squared plus 1 times x squared plus 2x plus 4 times x minus 2 times 3x minus 2 cubed. And then we can actually take out the e to the x squared plus 1 because, as I said earlier, e to the x squared plus 1 is always positive, and therefore, while it might affect the graph of the function, does not affect the sign chart of the function. Likewise, we can take out x squared plus 2x plus 4 because that polynomial is always positive. It's always above the graph, always above the x axis in the graph, and you can't factor it anymore, which means that it's just going to be positive. It's just going to stay like that. So it will affect the graph of the function. It will not affect the sign chart of the function, so we can ignore it. So the two factors that we actually need to look at our x minus 2 and 3x minus 2, we can see that this function is going to be positive because there's no negative sign. And if we add the exponents, we're going to get 1 plus 3 equals 4. So we're going to have even positive as our end behavior. So basically that's just going to be like a normal looking parabola, like a U shape, basically. That's all, just a U. And we're actually going to cross through the number line for both points because the exponent for both factors are odd. Okay, awesome. Now, for this problem, we can just go ahead and cross out the 1/5 and then the stuff that's in the absolute value brackets because absolute value is always positive, right? And 1/5 is always going to be positive. So again, it'll affect the graph of this function. It will not affect the sign chart of this function. So basically, we're just going to factor this as normal. Be sure to watch the double squared. You have x squared plus 2x minus 3, all in parentheses, squared. So be careful when you're factoring that. But basically, what you should get is negative x minus 1 times x plus 3, all in parentheses, squared. And then you can kind of separate, you can distribute that exponent of 2 and get negative x minus 1 squared and x plus 3 squared. So it cut off a little bit, but that final factor is x plus 3 squared. So we know that the behavior for this function will be negative. We see that negative sign. And it will be even because both of the factors are squared, right? So 2 plus 2, 4, even. And now we're just going to mark our number line here. And since both of our factors are squared, they have exponents that are even, we're going to bounce at both of the zeros. We're not going to go through the number line at all this time. All right, this next function is a little trickier because we have to know what the graph of a trig function looks like to make the sign chart. We can't just really just straight use the sign chart. So make sure that you know what the graph of trig functions look like, especially the graph of sine and cosine functions. That's very important because you're probably going to see that on a test somewhere. Basically, the graph of a cosine function kind of looks like this, and then it goes down, and then it goes up again, okay? So first, we're going to mark our zeros and our interval. So we're basically going to have the function stop at negative pi and pi. So we'll mark those two values down. And then negative 2 times cosine of x equals 0 at negative pi and pi over 2. So we're also going to mark those two down. And then we're just going to draw our function. We're just going to go straight through both the negative pi over 2 and the pi over 2. And this is what a graph of a cosine function looks like. For every single cosine function, it's going to look something like this. The zeros may vary, but it's going to look something like this. So we're just going to have to know that, remember that, and use that to make your sign charts. So this function will be positive from negative pi to negative pi over 2, negative in between negative pi over 2 and pi over 2, and positive between pi over 2 and pi. All right. So number 10 has a fraction. All you have to do is act as if there was no fraction. You can treat 1 over x minus 3 the same as you would x minus 3. So basically, in this problem, we're going to only have one factor. We're only going to have 1 0, and that's x minus 3. We know that this function is going to be negative because the problem is negative 6 over x minus 3, right? And since x minus 3 is to the power of 1, the end behavior for this function will be odd and negative. So marking that down, we're just going to write our 0 as usual, nothing fancy. And since negative, odd, end behavior always starts at positive and ends at negative, that's just going to be our line. Or I guess it's this way. Same thing for number 11. We just treat the fraction, we just kind of ignore it and we just move on with our lives. Don't really put too much thought into it. So we're going to make sure that the top is completely factored and that the bottom is completely factored. So factoring the bottom is going to give us x minus 6 times x plus 1. All right. And so then our zeros in this case are going to be -1, 0, and 6. This function will be odd and positive because as you can see, the original function has no negative sign. And if we add the exponents of all three of our factors, 1 plus 1 plus 1 equals 3, odd. And since all of our exponents in this case are 1, we're going to go through the number line at each of our zeros. So we're basically going to get something that looks like that. All right, number 12, this is the most difficult problem on this page. So some teachers don't actually use sign charts this way, and they will tell you to plug in numbers between every interval to determine whether or not the function is positive or negative there. Our method is faster and it avoids more mistakes, but it's hard for questions like this, and you're actually going to have to plug in numbers because I don't really know what this function is going to look like. So I can't kind of assume what the sign chart is going to look like. So I'm actually going to have to plug in numbers for every interval. So what we're going to do is find the zeros, then plug in points between those zeros, and then we're going to, like, based on the answers that we get for our numbers that we plugged in, we can determine whether or not the function is positive or negative in between all of our zeros. All right. So first, we're going to find our zeros, right? So we have kind of two factors that could equal 0, and that's how we're going to find both of our zeros. I'm doing the unit circle right now to determine what the zeros of cosine x equal to -2, negative square root of 2 over 2 are, and I get x equals -3 pi over 4 and x equals positive 3 pi over 4. So that's two of our zeros right there. And then we're going to determine where sine of x is equal to 0. And we're going to actually get x equals -pi, x equals 0, and x equals pi. So sine of -pi, sine of 0, and sine of pi are 0. So going back a little bit, you could see that cosine x is equal to negative square root 2 over 2. You might be wondering why we didn't make our factor equal to 0 like we did for sine of x. But technically, if you look at it, we actually did make it equal to 0 since we when we pulled out the sign from both parts of our sum and then grouped the rest of our parts of our equation together, we got cosine x plus square root of 2 over 2. So if we just kind of subtract square root of 2 over 2 from both sides of our equation, we're going to get cosine x equal to negative square root of 2 over 2. So now that we have all of our zeros, we can mark that down on our number line. And then we're just going to have to plug in values for each of our intervals. So I'm going to move myself up a little bit so we can see. So first we're going to plug in negative 5 pi over 6, because that's a good number in between negative pi and negative 3 pi over 4. And once we plug in that number, we can see that we get 1 over 4 times square root of 3 minus square root of 2, and that's positive, right? That's greater than 0. So that's one of our intervals down. We know that between negative pi and negative 3 pi over 4, the function will be positive. Next, I'm going to plug in negative pi over 2 to determine whether the interval between negative 3 pi over 4 and 0 is positive or negative. So if I plug in that, I'm going to get negative 1 over square root of 2, and that's less than 0. That's negative. Then I'm going to plug in, well, let me jot that down really fast. That's less than 0, negative. So that interval will be negative. Then I'm going to plug in a positive pi over 2, so I can find out what the interval between 0 and 3 pi over 4 is. And that'll give me a positive 1 over square root of 2, which is greater than 0, which is positive. Then we're going to have 5 pi over 6, which gives me 1/4 square root of 2 minus square root of 3. And that's actually going to give us a negative number, less than 0. So now that I've plugged in values for that are between each of the intervals that I wanted to figure out where the function was positive and negative, I can actually jot down where this function is going to be positive and negative. So since negative pi over 6 was positive, the function is going to be positive between negative pi and negative 3 pi over 4. Since negative pi over 2 was negative, the function is going to be negative in between negative 3 pi over 4 and 0. Since pi over 2 gave us a positive number, the interval 0 and 3 pi over 4 will be positive. And since 5 pi over 6 gave us a negative number, the interval between 3 pi over 4 and pi will be negative. So that's how you find the sign chart of more complicated functions. You do have to, unfortunately, find the zeros and plug in. And technically that method will work for any of the sign charts that we did on this page, but as you can see, it's much faster to find end behavior and zero behavior and draw the sign chart based on those two things, rather than all of this plugging in and stuff. So, as I said earlier, you're never going to be asked to just draw a sign chart, but you can use it as a tool to find answers to calculus questions, like increasing and decreasing, concave up and down, relative min and max, and we do have videos on all of those topics. So feel free to check those out once you feel comfortable doing sign charts, because sign charts will definitely make those problems much easier and go much faster. If you enjoyed this video, if it helped you in any way, please feel free to like it and subscribe to our channel for more calculus fun. Thanks!